In this video, we are going to put all of our transformations together. So just a little refresher, the values outside your function, so the a and the c, are vertical transformations. So the a is the vertical stretch, compression, reflection, and c is your up-down movement. The numbers inside your bracket represent horizontal transformations. So K represents the horizontal stretch, compression, reflection. And you have to remember, when you're thinking about your stretch or compression factor, you're actually taking the reciprocal of K. And then D is your right-left movement. And for that one, you have to look at the opposite sign of what's inside the bracket. Now, what's super important here is that you factor out your K value before you begin anything, because that is how our generic form is given to us. So if you don't factor out the K, you're going to be doing the incorrect right-left movement. So let's go ahead and try some out. Now, with our first example here, we're not given a base function we know. It's actually just a funky shape. So all we're going to do is start off with this funky shape with the key points that they gave us, and then we're going to apply the transformations. But before we can do that, let's do a little refresher on stating transformations. So the 2 is outside the function, so that is a vertical stretch by a factor of 2. Then the negative is the horizontal because it's inside the function. So there is a reflection over the y-axis. Then it says x minus 4 in the bracket. That means you're shifting to the right 4 units. And the minus 8 outside means shift down 8 units. So now, we have to do this in steps. I always do the A, the K, and then the shifting all in one step. So we're going to start off with the vertical stretch, then we'll do the reflection, then the 2 shifts we'll do in one. So I'm going to zoom in here, and now the vertical stretch affects your y coordinates. So these points here that are away from the x-axis, they will get further and further away from the x-axis. So we're going to double the distance. But the points that are already on the x-axis, they can't be stretched further away. So let's start with the point at 0, 3. When I double 3, I get 6. So now I'm at 0, 6. Then the point negative 1, 1. When I double the distance of 1, I'm now at negative 1, 2. The point at negative 2, 2. When I double the y coordinate, I'm now at 4. And same with negative 4, 4. And now we can connect our dots to get our stretched shape. And now I'm going to label this as 2 f at x, because all that's happened is the vertical stretch. Now we reflect over the y-axis. So this portion will go to the right, and this little part will go to the left when we reflect. So let's start with the point that's at 2, 0. It will now be at negative 2, 0. The point that's at 0, 6, I can't reflect an x coordinate of 0. The point that's at negative 1, 2 will now be at positive 1, 2. The point that's at negative 2, 4 will be at positive 2, 4. Then positive 4, 4. Then positive 5, 0. And now you can connect. And make sure you connect the coordinates in the proper order to get the correct shape. And now we can label this as 2 f at negative x, because we've added in that reflection. Now we can do all of the shifting at once. So I'm going to start with the point on the left, and I'm going to go right 4, and then down 8, and I'm going to plot my point right here. And then I'm going to do that again for the next point right at the top. So this point here, right 4, and then down 8, and I end up going right here. And then I'll keep doing that for all of my coordinates. And there we go. This should be our final shape. And I'm going to label this with the full transformation because we never stated that it is g of x. And there we are. Now we can state our domain and range. So the domain here, x is an element of all real numbers, but we have a range from 2 to 9. So x has to be greater than or equal to 2, but less than or equal to 9. And then for our range, our y value is between -8 and -2. So y has to be greater than or equal to -8, but less than or equal to -2. And there we are. So even though we have this funkier graph, we could still apply the same transformations. And when you're applying transformations, it's very, very important that you apply the stretches, compressions, reflections first, and the shifting is always the last step. Just like with bed mass, multiplication comes first, and the stretches, compressions, reflections are attached to your function by multiplication, so you have to do them first. Then the addition, subtraction, like your shifting, is done at the very end. Now, let's move on to a base function that we've seen before, and that is our parabola. So before I even look at my transformations, I'm going to go ahead and plot my base parabola. So the vertex, 1, 1, 2, 4, 3, 9, and the symmetry points. And connect, and then we can label this f at x. Now, let's go ahead and plug our transformations into our function, and then we'll label our function g of x. So I put the negative and the positive 6 outside the function, but instead of x, I'm going to write 1/2 x, and then I'll apply the exponent. Okay, so now I want you to pause the video, state your 3 transformations that we have, and then we'll check that, and then we'll go to the graphing. So pause the video here. All right, so hopefully you have a reflection over the x-axis because your a value is -1. There's no vertical stretch or compression though. The k value of 1/2, when I take the reciprocal, it is 2, which means I have a horizontal stretch by a factor of 2. And then the +6 outside the brackets means a shift up of 6 units. So I'm just going to start off with my a value, and I'm going to reflect my parabola over the x-axis. And when I do that, my parabola will now open downwards. So I'm just taking all of the y values and multiplying them by -1, but keeping the x values the way they are in my coordinates. And this I will label as negative f at x. Next, I will horizontally stretch by a factor of 2. So that means this arm here is going to get wider, and same with the left one. So now I'm going to take the x coordinates and multiply them by 2. So this x coordinate here is 1. When I double it, it is now at 2. This coordinate here has an x coordinate of 2. When I double it, it will be 4. This is 3. When I double, it will move to 6. And then the same on the left. So I'm just doubling the distance from the y-axis. And the vertex still hasn't moved anywhere. And now we can connect our dots, and then we're going to label this. And this is negative f at 1/2 x. And now we can finish up with our shifting up 6 units. So I'm going to take my vertex, shift it up 6. Then the coordinates that have a y value of -1, when I shift them up 6, they will be at +5. And again, the x coordinates aren't changing. The ones that are at -4, they will now be at +2. And the ones that are all the way down here at -9, they will now be at -3 when I shift them up. And here we are. And this I can label as g of x because I did state that g of x was that transformed function. Now let's state our domain and range. For a parabola, we know the domain is always x is an element of all real numbers because of those arrows that continue the parabola. But for our range, we do have a maximum value, and that maximum value is 6. So y has to be less than or equal to 6 because the parabola opens down. Make sure when you are stating your domain and range, you are looking at your final transformed function. That's why labeling and even color coding is really helpful. Okay, so now let's move on to another base function. And here we have our square root function. So I want you to pause the video and graph that base function and then come back. All right, here is our f at x. Looks like half an inverted parabola. Now, before we can write our function or state our function, we have to factor out this k value of -2. So what this actually is going to look like, we factor out the -2, and when we do that, that 6 turns into a -3 because 6 divided by -2 is -3. So that's what we actually want to graph. And if you wanted to, you could have put that into your function with the square root right away. So here I notice I don't have an a value, so I can start my square root right away. The -2 is the k, the -3 is the right left, and -8 is on the outside. So I want you to pause the video, write your transformations, and then come back to check them before we start transforming. Okay, so we should have a reflection over the y-axis, a horizontal compression by a half because we have to take that reciprocal, and make sure your compression factor is positive. The negative just tells us the reflection. Then shift to the right 3 and then down 8. So the k value, you can do it all at once. So you can reflect over the y-axis and do the compression all at once by multiplying your x coordinates by -1/2, or you can do them in 2 steps and do your reflection and then your compression. I personally like to do it all at once, but the choice is yours. So why don't you pause the video here and try it out. Try to do both of those transformations. And again, you can do them together or separately, and then come back to the video to see if you have the same coordinates as me. Don't worry about the shifting just yet. All right, so I'm going to take my x coordinates and multiply them by -1/2. So the one that's at the origin stays, but the point that is at 1, 1 will now be at -1/2, 1. The point that is at 4, 2 will now be at -2, 2, because 4 times -1/2 is -2. The point that's at 9, 3, that 9 will get multiplied by -1/2 to get -4.5. So it will be -4.53. And then you can connect. And I will label this as f at -2x because that's all we've done right now. So check your work to see if your method worked, whether in 2 steps or 1. Now we're going to shift everything to the right 3 units, down 8. So again, pause the video and then come back to check your work. So the vertex point is now here. Then we have a point here, a point here, and a point here. Make sure you connect and put the arrow on the correct side, and then hopefully it is labeled g of x. And there you go. And shifting, I personally like just do it all at once. Again, if you wanted to do it in 2 steps, totally fine. Okay, let's do our domain and range, and then we'll move on to the exponential on the right. So for the domain, x has to be less than or equal to 3. For our range, y has to be greater than or equal to -8. And there we go. Let's go to the next one. So here we have 2 to the power of x. So let's go ahead and graph that base function. So why don't you pause it and try it on your own to make sure you remember the base function. Okay, so here's our base function. Now the next thing, I know we have to factor out this -1 and we have to put it into our function of 2 to the power of x. So I want you to try to do this on your own. So again, pause the video and write your function g of x where k is factored out. Okay, so hopefully we have the 1/2 outside. Then we have 2. and it's going to be to the power of negative, but when we factor it out, the 6 will turn negative as well. And then the plus 3 on the outside. So check to see if you got that correct. If you made a mistake somewhere, check to see where you went wrong so you don't make that mistake in the future. Now again, pause the video and state your transformations. Okay, so vertical compression by a factor of a half, reflect over your y-axis, shift to the right 6 units, and then shift up 3 units. So the first thing we want to do is the vertical compression by a factor of a half. So you're going to take all of these coordinates and squish them in closer to the x-axis by multiplying the y-coordinates by a half. So go ahead and pause the video and try it out. So the 8 gets squished to 4, the 4 gets squished to 2, the 2 gets squished to 1, a half, and the rest just get closer to the x-axis. And there it is. This is 1/2 f at x. Now you need to reflect over the y-axis. Okay, so go ahead and do that. Take this exponential curve and it should get reflected so it looks something like this. So try it out and then come back to check with the video. Okay, so hopefully you have something like this. Okay, all of the points have been reflected over the y-axis. And now let's do the shifting all at once. Now, because we know that the exponential functions have an asymptote, the asymptote is affected by that up-down movement. So because I'm shifting up 3, I'm actually just going to draw a dotted line here, up 3 from the x-axis, so that I know everything will be above this, and then I can kind of guide my curve when I connect the dots. So go ahead and do your shifting now of right 6 and up 3, and then come back to check your final answer. And while you're at it, state the domain and range as well to check with me. All right, so hopefully your transformed function somewhere over here, which makes our domain x is an element of all real numbers and our range y is an element of all real numbers, but y has to be greater than 3. Make sure it's not greater than or equal to 3. Okay? Now, let's move on and try a sinusoidal. So we're going to do the cos function. So let's go ahead and graph our base function. And hopefully you remember that with cos, we are starting at the maximum. Now we do have to label our grid here, and I do want to see what we're going to do for our transformations. So actually I'm going to hold off on graphing my base function. So let's just actually put our transformation into our function. So the 2 will go outside of cos, and inside I am going to factor out that k value of 2, and 120 divided by 2 is 60, and then minus 2 on the outside. So I know I have a vertical stretch by a factor of 2. I know I have a horizontal compression by a factor of a half. I know I'm shifting to the left 60 degrees, and I'm shifting down 2 units. So I am going to make my scale on the y-axis go up by 1 so that I can fit everything that I need. So let's go back to our grid. Cos starts at 1, and every 90 degrees you're going to hit a key point going down to the midline, minimum, midline, maximum. And then we're going to continue this curve to the left as well. So down to the 90, and now connect the dots. And you should have somewhat nice flowing wave. And then make sure you put arrows at the ends and label it f at x. Now the first transformation we want to do is the vertical stretch by a factor of 2. So we're going to take all these key points at the maxes and mins, and we're going to double the distance. So let's go ahead and do that. And all the points on the midline, they're not going anywhere. And once you've done that, you can once again connect the dots. Just make sure there's a bit of a curve at the max and mins and it's not just very straight. And we will label this 2, f at x. Now the next thing, it is going to get a little cluttered on our grid, but we're going to compress this function by a half horizontally. So this maximum is not going anywhere, but the point that's at 90 is now going to be at 45 and negative 45 for the other. The point that's at 180, when I cut it in half, it's now at 90, so I'm squishing it in. The point that's at 270 will now be at 135. So now if you look at your little sketch, it looks like every key point is occurring every 45 degrees instead of every 90 degrees because of that 1/2 compression. So now let's connect the dots of what we have. But now we have all this empty space to the right and left of what we have. So I do want us to extend it, but I am going to extend it at the end to fill our whole grid. But for now, we'll just keep the shape that we have in front of us. So I'm going to label this 2f at 2x. Now for our shifting, I need to go to the left 60 and then 2 units down. Now look at your grid to see how you're going to move. If you check the grid on the x-axis, each square is 30 degrees. So if I want to shift to the left 60 degrees, I'm just going to move 2 squares to the left and then 2 squares down. So let's go ahead and do that. So this point here, I'm going to start with my maximum. 60 to the left, 2 units down. It will end up right over here. Then I'm going to do it for the points that are at 45. So 2 squares, then 2 squares down. Then the point that's at 90. 2 squares left, 2 squares down. Then the point at 135. And the point at 180. So there's one full cycle. And then we can do the same for the left side of the curve. So that we end up here, 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 and here. And now I do want us to connect the dots and then continue the pattern. If you look at every key point, it occurs 45 degrees apart. So on the right side, I'm just going to continue that pattern, and every 45 degrees, which is 1.5 squares, I'm going to go to a next key point to continue that wave. And then I'll do the same on the left side as well, because you want to maximize the use of your grid. And now we can label that g of x. And for our domain, XER, for our range, we have to include those max and mins. So y has to be greater than or equal to that -4, but less than or equal to 0. So make sure you look at that red line for your guides. Now when you're doing these sine functions, they do look very overwhelming. So if you wanted to just focus on this positive side and do all the transformations there and then continue the pattern and forget about the left side, that would totally be fine as well. Okay, let's try some more. So here we have another exponential one, but it's 3 to the power of x. So I'm going to make sure we can get the correct base function, and then I want you to pause the video and try this whole example on your own, then come check back with me once you finish. So for 3 to the power of x, I know my y-intercept will still be at 0, or at 1, sorry, because 3 to the power of 0 is 1. Then 3 to the power of 1 is 3, so 1, 3. 3 to the power of 2 is 9, so 2, 9. And then the other ones will just be really squished and close to your x-axis. So here is your base function f at x. Now, write your function as g of x, state your transformations, graph the transformations in 3 steps here, one for a, one for k, one for your shifting, then state your domain and range, then come back to fully check your answer. All right, so let's just take this up. For g of x, you should have the negative outside your function, then 3 to the power of negative x, and then plus 5 after your exponent. So that means we're reflecting over the x and y axis, and then we're shifting up 5. So from this base function, which is my black curve, I reflected over the x-axis and I get this blue curve. Then I reflected over the y-axis to get this green. And then I shift all of this up 5 units, including my asymptote. So my new asymptote is at 5. So that means my domain is xer, but my range, y has to be less than 5, not equal to it. So check your work, see where you went wrong, if you went wrong. If you did perfectly, then great. Let's move on to the rational function, which can look a little overwhelming as well, but let's try it out. So first thing, let's graph that base function. So pause the video, graph it, then come back. All right, so here is our base function f at x. Now let's write our transformed function g of x. Everything is horizontal for the most part. Make sure you factor out that 1/3. So you're doing 2 divided by 1/3, which really means 2 times the reciprocal, so 2 times 3, which is 6, and the minus 5 on the outside. So this means we have a horizontal stretch by a factor of 3, because we have to take the reciprocal, which means you're going to triple all the x values. Then you have a shift to the left 6 units, and a shift down 5 units. And remember, with the rational, because there is that, you do have 2 asymptotes, they will get shifted as well. Now, we're going to do the horizontal stretch in one step and the shifting in another. So I want you to try to horizontally stretch all of these coordinates by a factor of 3. So all of these will get pulled further away from the y-axis. So pause the video, then try it out. All right, so this point here is at 0.5. When I triple it, it is now at 1.5. This point's at 1, triple it, it's at 3. This point's at 2, triple it, it is at 6. But the y coordinates haven't changed. And then same thing on the other side. And make sure you don't go past where your asymptotes are. So now I'm going to label this f at 1/3x. Now, you're going to shift to the left, then down 5. So before I even shift, I'm going to draw in my new asymptotes. So if I go to the left 6, my vertical asymptote will get affected. So it is now at -6 instead of on the y-axis. If I shift down 5, my horizontal asymptote will get affected. So instead of on the x-axis, I'm now at -5. And now I have a guide for where these coordinates should lie. When I transform them or shift them, I should have one arm here somewhere and one arm here. So go ahead and take these new key points on the blue grid or on the blue graph and shift them left 6, down 5, and then come back and check your work. All right, so here we are. So I like to just take that central point and move it. So if I go 6 to the left, down 5, I get right here, and then I'll do my right and left point. And then same thing here. I couldn't actually fit this coordinate because it jumps off the page. So there's your g of x. And now for our domain and range, x can be anything except x cannot be that -6 for the asymptote. Same thing with y. Y can be anything except it can't be the -5 from that down movement. Okay, so let's try one last example for a sinusoidal. So let's go ahead and graph the base function for sine. And if you'd like, we can try this in a different way, where I'm just going to graph one cycle of my sine, and then I'll connect the dots, and I'm only going to transform this. I'm not going to worry about what's going on the left side, just so that I'm not overwhelmed, and I'll continue the entire pattern at the very end. So I'm going to label this f at x, and this might just avoid some clutter. Now, let's go ahead and write our function. So g of x is going to be negative sine. Then we open up our bracket, factor out that 1/2. So 45 is going to get divided by 1/2, which means it's actually getting multiplied by 2/1 by its reciprocal. So that's 90, and then the plus 3. So pause the video and state your transformations, then come back to check. All right, so you should have a reflection over the x-axis because of that negative a value, a horizontal stretch by a factor of 2 because we're taking the reciprocal. Then you have left 90 degrees and up 3 degrees. So let's go back to our graph here, and let's reflect over the x-axis. So pause the video, do your reflection, come back and check. So hopefully you just have this new wave where a max became a min and vice versa. Now we're going to horizontally stretch by a factor of 2. So take your key points and stretch them. Now some of these points might kind of jump off the page, but that's okay. So pause it and try it out. So this is what you might have. The only part that we were able to stretch was this little piece here, which turned into this giant hump. Now, we might actually want more. So why don't we just continue this? Because just by looking at this, I can see that now, instead of every key point occurring 90 degrees, it's 180 degrees. So I know that if I were to continue this wave, this would go upwards towards the maximum. But if I went to the left, it would go up to the maximum here and then down to the midline. So I'm actually just going to continue this pattern. So I didn't actually need the left side. I can do it on my own using my observations. Because once you know when every key point occurs, you're pretty good. So now let's just see what our shifting is. We're going to the left 90 and then up 3. So pause the video, take these key points, move them left 90, up 3, and then come back and check your work. And actually also do your domain and range to check. Okay, so here's what you should have for your function. Some of your points went off the page, but check to see if your key points work. Your domain is XER, and your range, y is greater than or equal to 2, but less than or equal to 4. And that's it. So just to recap, you're going to do your a value first in one step, or 2 if you want, then your k value, then the shifting in 1. So I will want to see at least 3 steps on there along with your base function.